everyone, this is Sudarshan Sharma once again here with a new video on a new topic. The topic is here before you, the human eye, the colorful world. This is the second chapter in physics and one of the very simple chapter. For your kind information, just I'm telling you that recently CBSE has removed a lot of content from this chapter and only a few topics are left. So what are the chapter which has been removed by the CBSE? We will not discuss for this session 2021 because of the COVID that has been removed. So for the time being, you remove it. And I'm also removing from my video. I'll not teach that. Just I'll let you know what are those topics, and the rest of the topic which are left I'll discuss in detail. So let's see. So the topic which has been removed is first topic is your human eye and its diagram and its description. And second topic, the defects, human eye defects, DEFECTS. So what are the various defects under this? That was myopia first, second was hypermetropia, third was your presbyopia, and fourth was your astigmatism, even power of accommodation, etc. So many things were cataracts, power of accommodation, these topics are no more now in CBSE syllabus. So no need just including this one topic also. So they have been removed from CBSE. Now you need not to go in more detail about their studies. So which topic are left out? I'll discuss that today in this video. Please see those topics. This has been removed. So you also delete for the time being. For just for your knowledge, if you want to read, it's your choice, then fine. So I'm going ahead. What are the topics left are dispersion of light, and second topic is scattering of light. So I'll discuss first of all today the dispersion of light, white light into 7 color. Let's see what does the dispersion say and what is the dispersion phenomenon. My dear, dispersion is a simple phenomenon of splitting of white light, the light which comes from the sun rays, into 7 color when we see it through the glass prism. This phenomenon we observe there in our day-to-day life when rainbow after rain shower, when the sun is just behind your head and you see the beautiful colorful 7 colors of the rainbow. So that's also because of the dispersion. So that's one of the very good phenomenon in the nature. So we call it golden eye. So you see the dispersion of golden smile also sometimes people say. So I'll talk about the dispersion of light. How do it take place and what is its definition? So DEF. So I'm just defining. So definition of dispersion. So what does your dispersion says? In simple words, you can write the split or the splitting of white light into 7 colors. Seven colors when it passes through glass prism. Now the question should come in your mind that where are the glass prisms when this is naturally occurring there in the nature after rain shower. So sometime even in the fountains your rainbow has been detected. So my dear, your microparticles of the water droplets also behave as tiny micro prisms. Because of that, sometime occasionally this phenomenon of dispersion occurs there in the nature. So this is a simple definition. I'll draw one diagram of the prism and that comes generally in the examination, and you have to make that diagram and show how do it bend. So this is definition, and with this is your glass prism, a triangular prism. We are making its front face, although it's other rectangular 3 faces and then triangular 1 face. So if suppose this is your ray of light which is striking, we call it an incident ray. Then we see that it is bending first reflection, and after that it is bending again second reflection and splitting into 7 colors. What are those 7 colors? You can write down and put it on the screen. So 1, 2, 3, 4, 5, 6, and one more you can draw. We write it, you can draw here a screen. This is a screen. On the screen you are making these colors. So these are written by Vibgyor, V-I-B-G-Y-O-R, Vibgyor. Because so you can see that your this color, which is your red color, the red color, it is bending least. This is called angle of prism A, this is B or C. So you can say this is incident ray, so this is your refracted ray. So this dispersion phenomenon occurs between the two extreme colors. One is your red color, R stands for red, R stands for red, O-R-A-N-G, orange, yellow, green, blue, indigo, and violet. So these are the colors. So we always write from downside with your V-I-B-G-Y-O-R. Your red color is bending least. What is the reason that why the red color is bending least and the violet color is bending most? The reason is that red color wavelength is highest. The red color wavelength is highest. So whenever the ray of light is passing from an optically denser medium, so its velocity decreases, wavelength decreases, and it is having highest wavelength, so it is bending least. Whereas the wavelength of violet color is least, so it is bending most. So you can make this diagram, and there is one more phenomenon, we call it dispersion when it's splitting. Is it possible that it can recombine? Yes, it's possible. So we call it a recombination phenomenon. Recombination. Recombination means when the splitted light recombine together and form again white light. So this is your white light, and white light where from we obtain? That is from the sunlight we obtain the white light, which is splitting into sunlight or white light. You can write it is splitting into 7 colors. You can take a piece of a prism and just do towards sun rays, and you will see, just rotate and you can see the different colors. Some of the colors are very much visible, and some of color fused together, that is mixture of the colors, you can say. So these colors recombine and make, these colors are making, recombining and forming, and this process is called recombination. So recombination, how to take place? These rays will strike here. I'm just from this only diagram I'm extending further, you can see, and these rays will recombine at a point, and your ray of light which is incident and will convert into white light. So this is called recombination. Means when we place an inverted prism, A dash, B dash, C dash, you can write, when we place an inverted prism, in combination with other prism, the splitted light recombine to form white light. So this is the dispersion phenomenon. how do it take place? How do dispersion phenomenon take place in the nature? That is in the form of a rainbow. Just I'll show you. Just see a beautiful diagram of dispersion of light in the nature. That is your rainbow. So I am coming to that diagram. So in nature, dispersion of light in nature. So suppose this is your water drop and this is your sunlight, sun over here, and the light you are receiving from here, a ray of light, and from here you see the banding of light occurs. I told you that a red color is banding least and the violet color is banding most. This is your suppose violet color, all other colors are in between them. So you will see that this color will come over here, and red color we will be see this side, and violet color is reflect. This is so basically this is happening in TIR type of reflection. Total internal reflection is caused over here, and we see a ray of light. What we see here is this is your violet and this is your red. So you can draw here a human eye which can see your different colors of the water droplets. So this is your water drop. Water drop. So what are the things responsible for a rainbow? Suppose this is your rainbow sometime which we see in the sunshine, and what after the rain. What are the conditions for this observing this rainbow? In this spectrum of 7 colors you will see. We call it a golden smile of the sky. Generally, when the rain shower, after the rain shower, or during the rain shower, or even in the fountains, we see rainbow. So this is your rainbow. How do it occur? It's looking very beautiful phenomenon. How can we see? What are the conditions to see the rainbow? The sun should be just behind your back, in front of your eyes. Only then you can see, observe this particular phenomenon. I can tell you my personal experience that generally whenever I see the rainbow, I have seen the rainbow is occurring from one of the river to the other river. I have seen this type of phenomenon also. Practically, what is the reason behind this? I told you that the tiny water droplets, micro water droplets behave as tiny prisms, tiny prism, and because of the combination of that, white light split into 7 color, and this phenomenon is called dispersion of light. You can draw this diagram for your rainbow. Why it is splitting into 7 color? That is because of the dispersion of light. Okay. So this is all for dispersion of light. Now I'll talk about one more phenomenon, that is your scattering of white light. Scattering. How do scattering take place in the nature? So that's the last topic in this, scattering of light. Scattering of light. So scattering, what is scattering, my dear? See, you see that in the morning when sun rays are not directly approaching to our eyes, even then we can see the things around us. You switch on the light directly where it is falling, okay, fine, reflection is taking place. And how do it scatter? What is the scattering phenomenon? See, suppose there is a microparticle in the air. So air is full of particles, atoms, molecules. This is suppose atom or a molecule of the air. There is oxygen, nitrogen, carbon dioxide, dust particle, water droplets. When these transparent atoms and molecules absorb the light, sun ray is falling on them, they absorb the light and they emit after that in all the direction. When they emit it in all the direction, this phenomenon we call as scattering of light. So how will we define it? The phenomenon of absorption of light, you can write white light also, white light by atoms and molecules of air and then re-emission of light in all directions is called scattering of light. Scattering of light. So it's because of the scattering of light that we can see the different phenomena in the nature. For example, I tell you that how do the intensity of light depends upon the the relation which we say intensity of light is inversely proportional to the fourth power of the wavelength. Here I represent the intensity whose SI unit is candela, and lambda represents your wavelength whose SI unit is meter. So Lord Rayleigh has given this direct relation, although this is not in syllabus. Just for your knowledge, you can remember this much is enough for you. So scattering phenomena, how we can explain the various phenomena in the nature. The blue color of the sky is because of the scattering. Why? So question is why the color of sky is blue generally comes in exam. You should know different things we explain with the help of white color of the clouds also. So these are all topics why the color of sky is blue. So these are the small questions which are asked there, and you can help with the help of scattering of light. You can explain the blue color of sky. See, red color wavelength is very high, so violet color wavelength is low, and the size of the scatter means atoms and molecules which are reflecting light in all direction. So the size of the scatter matches with the size of the wavelength of the blue color, and because of this reason the color of the sky appears to blue to us. And when the astronauts leave this atmosphere, they go just out of the atmosphere, the sky do not appear blue to them, this appears black to them. So the color of sky for the astronaut is black. It is due to the atmosphere here, because atoms and molecules are present of the air in the atmosphere only. So blue color, the answer for this which you should write is, since the atmosphere contain large number of atoms and molecules, blue color, the blue the red color wavelength is very high, comma, violet color wavelength is very low, but blue color wavelength matches with the size of scattering, size of SCATTERER, that is your, therefore blue color of sky is dominating all other colors. So this is the answer. You can write in short form also. So similar, so many questions comes from why the star is twinkling. We can explain with the help of the refraction of light, why the sky color is white, why the cloud color is white, and why sun is appearing little higher than its original position in the morning and evening, why the planets do not twinkle. And these are small questions which you can explain with the help of the phenomenon which I just discussed, reflection as and the scattering of light. So if you want any queries, you can just put in the comment box, and if you like my video, say thumbs up, give thumbs up, share my video. That's all from this chapter. Thank you very much.